Hey, it's always good to get faster, so here is my attempt at a speed run on Raphael's unequal pitch hip roof problem. I'm going to burn about a minute here. I'll just jump right into it. Looks like we're 15 seconds in, so here we go. The building, I believe, was 32 foot 6 for the eave by, and we're guessing 45 feet. Oops, did that wrong. At 32 foot 6, comma 45 feet. So there is our roof. Double check my lengths, 32.6, and that is correct. We wanted some pitches on this. They were going to be 8 and 12 for the long sides, 16 and 12 for the short sides. I'm going to come back and edit those. There's our roof. Let's change the pitches of these two to 16 and 12. Now we've modified that. Let's put in our hips. Hip valley. And we wanted a 2 by 8 in there, 7 1/4 by 1 1/2. Let's go ahead and put it in there, in there, in there. Let's put a ridge in. That was going to be 2 by 8 as well, 7.25. Just throw it in there, and let's get some rafters in here because we need to get the common length for those. That's one of the, and 2 by 6, 1'4" spacing. I'll just center that spacing on the building. There we go. So usually these things don't, the automatic ridge doesn't put it in at the correct height, and I can see that we'll change our view. We can see the ridge is at the wrong height and the rafters are seat cut over the ridge. We don't want that condition, so I'll change back my visibility in my view, and I'll trim all the rafters off. To the face of the ridge. Do the same thing on the other side. There we go. Rafters are cut back. Let's look at it up in view again, and we still have that problem where the ridge is dropped, so we'll move the ridge in its Z location from that height up to this height. And now we should have the proper condition for the ridge. We're not back cutting the ridge, we're just leaving the ridge cut flat. Next thing I need to do, I suppose, is look at the ridge cut condition. Right now the ridge is running, well, this would be our theoretical ridge length. Let's see if I can, oh, I can't grip edit that. Look at that. Let's go ahead and double cut this ridge so that it pockets around the two hips. I'm guessing that's the way you guys do this. Again, I don't do a lot of this type of work out in the West. But if we were to double cut this ridge, we'll cut it at this on this plane. And with this plane, now that ridge is double cut properly, or I'm assuming properly anyways. We'll do the same thing on the other side so we have the geometry right. Go back to my proper view, edit, double cut this ridge along that side and this side. do that properly. Back and do it again. Ridge is what I want to cut. I want to cut this side off. Ridge is what I want to cut. And I want to cut this side off. So there we go. Now the other end of the ridge is double cut. And we had some, so I think I've got the geometry right of what the problem asked for. Let's create some shop drawings of this stuff so we can answer Raphael's question. First thing we wanted was the 8 and 12 common rafter length. So let's go ahead and shop drawing. Let's grab one of the 8 and 12 commons, throw it out here. Clean it up a little bit. And the overall length for that 8 and 12 common length is 19.5 and 7/16. Second thing he asked for was the 8 and 12 ridge height. Well, we don't have any walls in this. We weren't given a wall height, so coming off the floor is kind of irrelevant. So let's look at it from the standpoint of the theoretical fascia line. So distance from the theoretical fascia line to the top of the ridge is 10 foot 9.5 right there in the Z height. So that's our ridge height. As for 16 and 12 commons, but we don't have any 16 and 12 commons on this. These are all jacks. The way I like to handle this is to create two shop drawings. So I'll do that. Shop drawing. It's correct. And I'll grab one of the longest ones and put it over here, and I'll grab the next one. So these are the two different, oh, move the tags. These are the two jack rafters that I had selected. And so for overall length of the jack rafter, let's go long point. And we'll do the same thing on the other one. This will now give us a difference between the two that'll be consistent throughout the length. So now we've basically identified what all of these jack rafters are. I can do the same thing for these jack rafters, but Raphael didn't ask for it. That was the common hip and valley length and pitch. Let's get that. Do the same way. Here is the hip, or the yeah, hip, I guess it is. And a little bit of cleanup to make it make more sense. The hip length, we'll just do the length along the center line of that hip. The length along the center line is going to be from there to there. There's the length of the hip. The pitch was given to me automatically of a 30.81. And finally, the hip bevels. Those are given in the end view right here. I think most people like to have that number from the vertical on your saw, so we will dimension it this way. And those are the angles for the back cutting of the hip. And that's it. Time. 9 minutes and 43 seconds. You got shop drawings, all the angles, everything that was asked of us, and the difference between the two. Yeah. Still maybe slower than a production roof framer who does this every single day, but I don't think it's so bad. Have a good day.